Hi everyone, in this video I'm going to go over how to conduct a dependent two-sample t-test in Excel for your homework. I am using the Phase 8 data that's from a national survey, and you will also be using this data for your dependent two-sample t-test. But you should look at the homework instructions to determine which variables you should use based on the first letter of your last name. I am going to be using weight in 1997 and weight in 2013. You won't be using those, but you can follow along if you like to make sure you know how to do this with the data I use before you do it for your variables. Alright, so this is a dependent two-sample t-test because we have 2 time points, and I'm using the time point in 1997 and the time point in 2013. And I'm going to compare the weights. So this is paired, which means it's a dependent t-test because we have weights from the same person at 2 time points. So they're paired by the person. This is also called repeated measures. And here we have person 142, that's their ID, and we have a weight of 161 and also 150. So that was their weight in 1997, and this is their weight in 2013. And also for person 178, we have a weight of 110 in 1997 and a weight of 165 in 2013. So it's paired by person. And what we're going to compare is the differences between these two. So basically what the paired t-test is going to do is going to subtract these by each person and make different scores. It's not going to do that work for you, but I'll show you how you can make different scores. And then it's going to average those different scores and see if it's significantly different from 0. So to do a dependent two-sample t-test in Excel, we're going to go to Data, and then Data Analysis. And then I'm going to scroll down to find the t-test paired two-sample for means. So paired means dependent. They just called it paired in Excel. And press OK. Then I'm going to click here, and I'm going to find the first year and click the whole row by clicking up here on the letter. And then press this to get out of that, and then variable 2 should be the second year. You could do it the other way, but I think it makes more sense to do it in order. Okay, and then the hypothesis mean difference, that's just going to be the number in your null, and for a two-sample test, that's always going to be 0 for this class anyways, and generally it's always 0 anyways. And then I'm going to press labels and make sure that's checked because I have variable names here. I have weight 1997 and weight 2013. And then I'm going to keep the alpha at 0.05, but if you want you could change it. And then I'm going to make it go into a new worksheet, a new tab, so I'm just going to leave that and I'm going to press OK. And then just wait a second and you'll have the results, and you don't have to do all the math. It's in Excel great. Most of the time, anyway. Okay, then I'm just going to expand the columns a little bit so we can read it better. Okay, and you should also note that Excel takes the first variable minus the second variable. So when you write your hypothesis, you want to make sure that lines up with how you subtracted in Excel. So it's always first minus the second. So make sure your hypothesis and the Excel that you do line up. If they don't, then this t-statistic is going to be not the right sign. So if it was supposed to be positive, then it's going to be negative. But here I'm doing weight 1997 minus weight in 2013. And then the output gives you the means, and then the variances per each time point. Now Excel doesn't use this variance information to get the standard error for a dependent t-test. It uses the standard deviation of the different scores, and I'll show you how to get that in a little bit so you understand a dependent two-sample t-test a little bit better. It has a number of observations, and since each person had 2 weights, they have the same number of observations. Then we have the Pearson correlation, which we can do for a dependent t-test because they're paired by person in this example. Then our hypothesized mean difference, which is the number in the null. Our degrees of freedom, which is the number of people minus 1. We have our t-statistic. And then we have our p-value for a one-tailed test. And because it's e to the negative 72, it's basically 0. It's like 0.00000 for a long time, and then it's 3. But it's basically 0 here. So review scientific notation if you don't know what that is. Then we have the t-critical for a one-tailed test. Now this is the critical t for the rejection region method, which is usually taught in the intro to statistics class. In this class, I chose to emphasize the p-value approach because that's what's used in published literature. But I do have a couple of documents about the rejection region approach if you'd like to use it. And then we have the p-value for a two-tailed test, so make sure you use the right p-value based on your hypothesis, your research hypothesis, to be specific. And then we also have the t-critical for a two-tailed test, so this is also with the rejection region method instead of the p-value method. But you can also use this critical t for a confidence interval. Alright, so we did the first part, but then another part in your homework asks you to create difference scores, and then get some descriptive statistics about the difference scores. So this is what Excel gives you for the dependent t-test, or the paired, that's what it's called in Excel. But you can also get this information kind of a different way, and the other way kind of helps you understand what Excel is really doing. Sorry, I had to plug in my laptop, but I'm back now. Alright, so I was telling you that the information that Excel gives you about the variance can be important, of course, but it's not the variance or the standard deviation that it uses to get the standard error. So I'm going to kind of show you another way to do the dependent two-sample t-test, and hopefully that helps you understand it a little bit better. So I'm going to make a column for the difference scores. Alright, and what I'm going to do is going to click there and press on the first cell here, or the second one I guess, but it's the first one after the title of the label, and which equals. And then I'm going to click on the first weight in the first year, and I want the cell letter and number to pop up for me. And then I'm push minus, and then I'm going to go to the weight for the 2013, and also I want the cell letter and number to come up. And the reason I want that to happen is so we can repeat this formula over and over again for everyone. So this did 161 minus 150, and that equals 11. So this person actually lost weight from when they were younger, which is not what I hypothesized. I hypothesized the other way, but so let me show you what I did. So I clicked here. Sorry, I did that really fast. So I was here, right? And then I double clicked here on the bottom right corner, and this little crosshair comes up. Sometimes if that doesn't work, I don't know. Sometimes it's weird. But you can drag also. But make sure you drag all the way to the bottom so that everyone has this different score. So for here, this person actually gained weight. So it was 160 minus 185, then that's a negative 25. So that means they actually gained weight. So maybe it might have been better to do it the other way, but it doesn't matter. So a negative means they actually gained weight. But I decided to do this way, my hypothesis, so I'm going to stick with it. Alright. So then what I'm going to do is I'm going to get the descriptive statistics for the different scores. So I'm going to go to data analysis. We've done this before for other variables. And go to descriptive statistics, press OK. Input range, and I'm just going to highlight the whole row of different scores. So it should be J for me. And group by columns, and I had a label of difference there. And then I'm going to put it in a new tab. Don't want to leave that. And I'm going to check here summary statistics. Press OK. Great. We got that pretty quickly. Just going to make it bigger for you. And then so here's the mean of the difference score. So I made a difference score for each person, and then Excel found the mean for that. And then it found the median and the standard deviation and stuff. And it also found the standard error for me. So that standard error is based on this standard deviation for the difference scores, not the individual variance or standard deviation for each time point that the paired two sample data analysis tool did. So it's a little different, but this is how it got the T. It just didn't show you all this. So I'm just gonna click on a empty cell and push equals, and I'm gonna find the T statistic. So it's just the mean, and it's basically the mean of the difference score minus 0, but you don't have to do minus 0, divided by, and I'm gonna put a slash there, the standard error. Look, I got negative 22.28, and that's what we got from here. So it matches up. So I like this way a little bit better. Well, there's different advantages for doing either way. Like this way helps, the difference score helps you understand how it's doing it. And this way might give you some other information that is helpful. Alright, and that concludes this video. Good luck on your homework.